Okay, and we're looking at this problem. It says two professors teach an introductory stat course, and the table shows the distribution of final grades reported. We wonder whether one of these professors is an easy or greater. So first thing we want to do is find the expected counts for each cell in this table. So I'm going to copy the table into Excel and then create the expected counts cell as well. Okay, so there's Professor Alpha and Professor Beta. So I want to create another one, so I'm just going to paste it again. But this one I want to be of the expected value, so I'm going to take those numbers out. Now, in order to get the expected values, the first thing you need to do is find your totals. Your totals for A's, B's, and C's. You can just say equals the sum of like the A's here. And then you can just drag that down, get the thin one, and do a left click. And then we need the totals for like Professor Alpha as well, and then also for Professor Beta. And then we need the total of the whole thing, which we can go this way is 83, or if you do this one, it should sum also to 83. Okay, and so this is the total. So to figure out how many you expect to see, you take the percentage in the totals of A's that are given, 13 out of 83, and then you multiply, that's the portion, 13 out of 83, you multiply that by the number of students that Professor Alpha had, and that would tell you how many A's you should expect if it's independent, if it doesn't matter. So I do equals, I'm going to do this number divided by the 83, which I'm going to make an absolute reference. So I'm going to put F4 on, and then I'm going to multiply that by the Professor Alpha total, which I'm also going to make an absolute reference. And the reason I'm going to do that is now it's going to allow me just to drag this down. Because see, now to get the number of B's that we would expect for Professor Alpha, we would take the number of B's, which is this E12, and then we would divide by the big old total, which is the E15, and then times the number of students that Professor Alpha had. Now to get Professor Beta's numbers, you're going to do equals the total for A, so E3 divided by the E15, which we're going to make an absolute reference, and then we're going to multiply that by the total number of students that he had, which will also make an absolute reference. And then we can just drag this down to fill it in, and you'll see that the way that the number of B's that we would expect for Professor Beta is calculated is it took the total number of B's divided by the total number of students, so that's why I did E12 divided by E15, and then multiplied by the number of students that Professor Beta had, which is the D15. I'm going to pause for a second and put these numbers in. Oh, they want this rounded to 3 decimal places. So if you do a right click and then format cells and then number and then put 3 there, it makes it easier when you're typing it in. Okay, so I'm going to check my answer. Good job. All right, continuing on, it says, test the hypothesis about the two professors. The null hypothesis is that they're the same, and the alternative is that they're different. So that would be choice A here. Okay, and we want to test it at a significance level of 0.05, so we're going to need to compute our chi-squared statistic. So how do we do that? Well, remember, for your chi-squared for each cell, you're going to do the observed, so in this case, put your equal sign in parentheses, you'll do your observed number of A's minus your expected number of A's, and then you're going to square that, and then you divide by your expected. And hit enter. And this is kind of fun because the computer knows if you get the small plus sign and click and drag, it's going to know to fill these all in. This will be B's, C's, and below C's, and you can kind of check it. But that is doing C12, which is the observed number of C's, minus C12, which is the observed number of B's, minus the expected number of B's, and squared and divided by the expected number of B's. Okay, and then all you have to do to get the chi-squared statistic is to sum all of those numbers. So we'll just say equals and then sum, and then come in here and add these up. And so 5.315 is our chi-squared statistic. Make sure I'm rounding to the right amount. Okay. And then now they want us to compute, I'm going to run out of time, so I'll finish this one in just a second.